All right, people, welcome to side and angle relationship triangles. It is Tuesday, March 30th. Here we go. Do some notes. So the first thing we're going to do is label the triangle. So I'm going to label angle A right here. And angle A is going to go alongside with side A. It's across the triangle. We worked on this yesterday. Okay. So side A goes along with angle A. I'm going to switch colors here. I'm going to go over to angle B. Angle B is going to go across to, you guessed it, side B. I'm going to switch colors once more. And angle C is going to be at the top. And the side that goes along with angle C is at the bottom, across the triangle. Okay? And it's important that we know that the angles correlate with the opposite side. Okay? It's very important that we remember this. Okay? The next little section of the note says relationships of sides and angles of isosceles triangles. Remember, isosceles triangles are when we have two equal sides, usually denoted by that little hash mark on the triangle. Okay, in an isosceles triangle, the angles opposite the two congruent sides are congruent. So what does that mean? It means that over here, I've got side A goes along with angle A. Side B of my triangle goes along with angle B, just like we did before. But notice I left the same color because they are the same length for the sides and the same length of angles on the angles. So if I label my triangle like I did above, I would essentially want to label it as hard coded like this. Okay, where A and B are the same color because they are the same value. So what does this mean? It means the measure, that's what this little M stands for, of angle A, this means the measure of angle A. So the M is measure, little angle picture is angle, A stands for angle we're talking about. Measure of angle A is equal to the measure of angle B. They're the same. So that's really cool for us to know because if we're given a value for angle A, we immediately know what angle B should equal. If we're only given angle C, we could subtract angle C from 180 but split up the remainder that's left. We could split that up by 2, aka divided by 2, and we'd be able to find both of the angles. So isosceles triangles properties are pretty sweet. Okay, I want to go through an example with you. Example 1. And it says find the value of x and y in the triangles below. So how are we going to find y? Well, I notice that y is a part of the length of RS. It's trying to tell me that length RS from the bottom corner up to the top is y minus 2 centimeters. Well, that doesn't mean much to me. However, it does have a congruent side by this little hash mark that's in the side of the triangle. So it's congruent to ST, which equals 7. So take a look. If I do line segment RS, I know that that's going to equal line segment ST. I color-coded it green for you up there. I can substitute y minus 2 for the length of RS, and I can substitute 7 in for the length of ST. I could simply just add 2 to both sides. These two bozos will cancel out. And we'll be left with y on the left. When I take 7 plus 2, that will give me 9. So the value of y equals 9. How could we solve to find x? Well, I'd have to take a look at some properties here. I know that the opposite angle goes with the side. So this goes here, and this one will go across to the other. But here's the thing. Side RS and side ST, we have highlighted green, they're the same. So what does that mean about angle R in the corner and angle T in this corner? It means that they're the same. Angle R is the same as angle T. Well, what does it say the value of angle R is? It says that angle R is 35 degrees. What does it say for the angle of T? It says 7x. So all that I need to do here is I'll divide both sides by 7. That'll cancel out this multiplication of 7 with the division of 7, so both those go away. 35 divided by 7 gives me 5. And 7 divided by 7 leaves just 1x, which is what I want. So x would equal 5. Take a moment and try the one on the right by yourself. Works the exact same way as what we just did. Okay, so let's go over this one. I have to think what two sides are equal. H to G is equal to K to G. If that's the case, I can just replace what is given to me for H to G. H to G is y plus 3. K to G is 10. So to find what y is, all I would have to do is simply subtract 3 on both sides, and I'll end up getting y equals 7. Okay. Now to find x, I have to do the same thing I did before. I have to realize that angle K is equal to angle H. Angle K equals angle H. If angle K is 72 degrees from the picture, and H is 12 times x degrees, then all I would need to do is some simple algebra and divide both sides by 12. If I divide both sides by 12, it gets rid of these two bozos, I'm left with x on the right side. Then 72 divided by 12 is 6. All right, so the next part is talking about equilateral triangles. And equilateral triangles are super duper cool because all of the sides are the same. When all of the sides are the same, it actually forces all of the angles to also be the same. Because remember, there's a relationship between the length of the side and the angle that goes with it. Well, if all the sides are the same length, then it must mean all of the angles are also the same length. In an equilateral triangle, all three angles are congruent. And each measures exactly 60 degrees. We talked about that earlier. It measures 60 degrees exactly. Equilateral triangles can also be called equiangular triangles. Okay, because equilateral is describing the sides. If we replace it with this word equiangular, it's the same prefix, E-Q-U-I-L, and we're going to to put after it the word angular. A-N-G-U-L-A-R. Equiangular. Means all of the angles are the same, since they have 3 congruent angles. So let's take a look. A real mathematician would label this equilateral triangle with these same hash marks in all 3 sides. That tells us that they're the same length. Because of this relationship, look what happens. If this side is the same as this side, and this side same as this side, all of these angles are going to also be congruent, the same. So what happens is angle A plus angle B plus angle C should equal the grand total of degrees of the angles of the triangle, no matter what shape it is, 180 degrees. Doesn't matter what kind of triangle, always 180 degrees. Well, there's only one combination of numbers where all 3 angles can be the same. And that, my friends, is 60 degrees. There's no other option. If any of those 60s are a different number, if any of those numbers are different than 60, and it still equals 180, well, then guess what? It means the sides are different lengths. Okay? Let's take a look at example number 1. Then we'll move on to some partner practice. In example number 1, we want to find y. And it works the same way as we did before. We do y. We want to find it. And we know that it's on the bottom here. Is the length WZ. WZ is going to equal the other side. Well, WV doesn't have anything labeled over it. We don't have any information, so that's not going to help us. But on side VZ, it does help us. These guys are the same length, but it's telling us that equals 25. So WZ is the same as VZ. And WZ, when I replace it, it's going to be 5y. And VZ shows me 25. If I simply divide both sides by 5, get rid of that multiplying by 5 on the left, it gives me y equals 5. And that would be my answer. For solving to find y, that's all we have to do. How can we solve to find x, you may ask? Well, I don't have any other angles on here where it tells me how many degrees it's supposed to be. I just know that they're all the same. Friends, because it's equilateral, I know that each of these has to be 60 degrees. There's no other option. It's a rule. If I were you, I would commit that to memory, where if we have an equilateral triangle, all the angles have to be 60 degrees. It'll be helpful to know that. If you ever get stuck, though, you always could just end up taking the 180 divided by 3, and it'll end up giving you 60 degrees for all 3. So even if you forget, you can still figure it out. You're just going to split it up evenly because they're all the same. But it makes it helpful to know that it's 60 degrees. If you can just remember it, it'll make this go a lot quicker. So if I want to find angle W, I know that it has to equal 60 degrees. Angle W can be replaced by 4x equals 60. To find x, you simply divide 4 on both sides. Cancels those out. X by itself will equal 60 divided by 4, which is 2. Let's take a moment and let's move forward to partner practice. And then whenever you guys don't finish, make sure that you keep working on it, check the key online, and then make sure you remember that your test review is due tonight by 11:59. Okay? Have a great day, everybody, and I'll see you